Alright, so I'm going to quickly go over the pre-assessment. So we have our base 10 numerals, our numbered names, and the expanded form. I may just go down here, so 570 thousandths would look like 0 and 570 thousandths. Here is 2 and 3/10ths and 4 100ths and 9 1,000ths, so this would be 2 and 3/10ths, 4 hundredths, and 9 thousandths, or 349 thousandths. And now let's look at number names. This would be 4 and 37 hundredths. So remember that we just say that number after the decimal point and figure out what place value it's in. Here we have 2 and 349 thousandths. And then when we're looking at expanded form, that's just using this kind of multiplication and thinking about place value. So I have 4, which is in the ones, plus 3, which is in the tenths. Oops, 3 times 1/10. Because 3 times 1/10 is 3/10, plus, and I have a 7 in the, times 100ths. So my 4 and 37 hundredths is 4 times 1, plus 3 times 1/10, plus 7 times 1 100th. And we have 507 thousandths. So I have a 5 times, that's in my tenths, plus a 7. That is, oh, I messed up here, 507 thousandths, see? So that'd be 0 and 7. I had 570 thousandths, this would be 507 thousandths. You could respect the place value and put 0 times 1 and 100th, or you don't need to do that, and you can just do 7 and times 1 1,000ths. Okay, so I know it's kind of some chicken scratch, but let's use this the best we can. The next group is write the symbol greater than, equal, or less than to compare the decimals. Here I'm looking at the ones. We have the same digit in the ones. I move to the tenths. This one is an 8. That's a 0, so that means this is greater. Here we have zeros in the ones column. We have a 4 in the tenths and a 1 in the tenths, so that means this number is greater. Here we have a 0 in the ones. We have a 1 in the tenths. We have a 9 in the hundredths here. That means this one is greater. Order the following by putting them in approximately the correct. So if I have 0 and 1, I know this is going to be half, so that's going to guide my way. 0.4 is close to half, so I'm going to put that about here. 0 and 402 thousandths. 0 and 42 thousandths, that's going to be pretty close to 0. 246 thousandths, that's going to be somewhere in between these two. And then 891 thousandths, that's going to be somewhere over here. So again, we're looking for approximate. I could probably move this down further now that I think about it, because it's going to be close to 0.9. All right, next one. Let me change it around a little here. Actually, hold on, I'm going to pause it. That gives me more space. Now I'm supposed to round each number. And I'm going to take this number and round it to the nearest 1, 10th, and 100th. So I'm going to round it to the nearest 1. I look for my 1's place value, and then my 1 place value to the right, which is ninths, which is tenths. So since this is 5 or greater, which it is, I'm going to be rounding up to 5. We'll do the same here. I have 3, and then my number in the tenths here is 0, so that means I'm going to be staying the same or going low. Now I need to do the nearest tenth. So I'm going to go back. I see my tenth here is a 9. The number next to it here in the hundredths is a 4, so that's less than 5. So I'm going to be keeping firm here with my tenth. Here I have find that tenth. Here's 0, and I go to the right. I see a 5, so I'm going to be rounding up to 3 and 1/10. And now we're going to thousands, so I need to look at, or nearest hundredths. So I need to look at my number in the hundredth, which is a 4. And that number right next door, which is a 6, since that's over 5, I'm going to be rounding up to 495 thousandths. Here I have a 5 in my hundredths, and to the right I have a 3, so that's less than 5. So I'm just going to hold tight at 5 hundredths, so I have 3 and 5 hundredths. Alright, find the answer to each problem, show your work. Let me take those things off of there. I have 4 and 62 hundredths plus 2 and 99 hundredths. I think I'm going to do the the give and take. So I'm going to take 1 from 1 hundredths from 462, or 4 and 62 hundredths to make it 4 and 61 hundredths. And I'm going to add a hundredth here to make that 3, which really simplifies my life greatly. So that would be 7 and 61 hundredths. Here I'm subtracting. Let's see here. It looks pretty much in order. I don't know if I need to do anything too much, but I do need to show my work. So I'm going to start, I'm going to have my line. I have 7 and 89 hundredths. I'm first going to be taking 3 away. So I get to 4 and 89 hundredths, and then I just need to take 2 tenths away, which gives me to 4 and 69 hundredths. That's my answer, 4 and 69 hundredths. Find the sums and differences. Again, you can do the standard algorithm, or you can adjust. Sometimes it's better to adjust, sometimes not. Let's see here, 8, 9, yeah, that's pretty straightforward. 139 and 8 tenths. Here, I have a lot of carrying to do. If I just go bump it up 2 hundredths, I can change this to 5. I'll be taking 2 hundredths from here, which would be taking me to 2 and 32 hundredths, and add those together. Much easier problem. 7 and 32 hundredths. See, I didn't have to do any of that carrying. Gosh, the giving and the taking is just so great. Subtracting. Remember, I need to keep things equal if I'm going to be changing anything. I see some zeros here. I'd like to get this to 4 and 99 hundredths. So that means I need to go down to here. I need to keep that distance the same. So since I moved down 2 hundredths, I need to move down 2 hundredths here to 2 and 38 hundredths. And remember to subtract to get 2 and 61 hundredths. And here I got 1 and 83 hundredths minus 0.9. I wonder if I could keep it the same. I wonder if it would be good to just go 1/10 up. So if I go 1/10 up to 1, so that means I would need to add a tenth up here to get me to 93 hundredths, and then subtract. That's going to give me 93 hundredths. All right, see those strategies making a world of difference rewriting that problem. Number 7, the football stadium in our town holds thousands of people. Today is Kids Day, and they're only charging $2.40 admission. Complete the table below to show how much money they'll take in for different numbers of people. So if we have 1 person, that's $2.40. If we have 10 people, that's $24 even. So again, we're just adjusting that place value 1 to the left. $240, that would be 100 people. 1,000 people would be $2,400. And 10,000 would be 24,000. What happens to the numbers of zeros in the product is you multiply by a number by 10, and then by 10 again, and then by 10 again. Why? The zeros increase, okay, for every 110, you create a new place value filled by the numeral 0 or digit 0, something like that. If you put I add zeros, then I'm not going to be happy about that one. John was looking at the table above. He noticed that when you multiply a number by 10, then by 10 again, and then by 10 again, the decimal point moves over to the right by 1 place every time Explain to John why it works this way. But see, I would discourage John from thinking like this. I would say, John, that decimal point isn't moving anywhere. It's always between the ones and the tenths. Right? I mean, that's one way to think about it, but that's not what's really happening, John. So, John, I think I'm going to disagree with you. And I'm going to say the decimal point is always between the ones and the tenths, so it's not moving. It just appears so. Alright, here we're doing is some converting. We have 1 kilometer is 1,000 meters, 1 meter is 100 centimeters. How many meters in 34 kilometers? So that'd be 34 times 1,000, or 35,000 meters. How many kilometers in 34 meters? So that would be 34 divided by 1,000, or 0 and 34 thousandths. There we go. How many centimeters is 5 1/10 meter? So that would be by 100, adjusting two place value spots. So that'd be 501 centimeters. How many meters is 340 centimeters? So we're going to be dividing by 100. So moving two place value spots to the right. So it would be 3 4/10 of 1 meter. All right, moving up. Choose one division combination below. Circle it. Pick the one that seems best for you. Not too hard, not too easy. Write a story problem. Use the grid. So I'm not going to necessarily go over all 4 of these. What I'll probably do is I'll have 4 different models for you. Maybe we'll see. Maybe we'll just check these together. This one when you answer it. And then 4, the 5th graders are going on an overnight camping trip. In all, there are 140 kids and adults, and they're traveling to the camp in passenger vans. If each van can carry 12 passengers, how many vans will they need to get everyone there at the same time? Write an expression to match this problem. So that would be 140 kids and adults. Oh, wait a second. So maybe it would be, well, it's how many kids are going into each van. So it seems like a division problem. So it's probably something in terms of 140 divided by 12. Use numbers, words, or labeled sketches to solve the problem. And again, I'm going to be thinking about real life, so like vans. And so I'm not going to have remainders in real life, right? If I have a remainder, it just means I need an extra van. There's different ways we can go about doing this. If I have my one van, and I know it has 12 in there, I could probably count those out and see how many gets me to close to 140. I could be thinking about my area model and thinking about how that could be 100, and then I have 10, and then I just have, 10, 20, 30, 31, 32, and I just have 8 left. Well, if I think about it this way, this is the 12, right? And I know this is 10, so that would be 10 vans, right? 12, that's 120. This would be 132. And then I would need this one with this 8 there. So that's going to tell me I need 12 total vans. 12. 11 of them will be at capacity, and one will just have 8. Está bien, I lose. Gracias. So some sort of work like that would look good. I really like this. The more that I learn these strategies and work with them, the more I find them extremely useful. All right, thank you.